Hi friends! In the last video we looked at long division of polynomials, which is a great skill. Turns out sometimes you don't have to use long division in order to divide polynomials. We have another method called synthetic division, and it doesn't mean fake division, but that's kind of what it sounds like. It's just a different method. Now, synthetic division we can do when we are dividing by a linear term, remember that means x to the first power, with a coefficient of 1 on the x. That's what's important, is that 1 as a coefficient and 1 as an exponent on x. When we have that, we can do synthetic division. Now, synthetic division looks a little funny at first. However, most students really like it because it's pretty straightforward. So what we want to do is we want to start by writing out the coefficients of the number we're dividing by. In this example, I have x cubed minus x squared plus 2x plus 5, and I'm dividing it by x plus 1. By the way, this is the same example we started with in long division. All right, so I'm going to write those coefficients. So I would have a 1x cubed, so I would write down 1, then minus 1 for minus x squared, then positive 2, and then positive 5. So across the top, 1 minus 1, positive 2, positive 5. I'm going to skip a line underneath that, and then I'm going to draw a horizontal line a little ways down. And then up next to that 1 on the left-hand side, I'm going to mark a little box. And in it, I look at the number I'm dividing by here, x plus 1. And we want to think about the number that would make that 0. So to make x plus 1 equal 0, well, then I would subtract 1 from both sides, and I get x equal negative 1. That tells me negative 1 is what's going to go in this little magic box on the left-hand side. All right, so here's the process. First thing we do is we bring down that first number, the 1. We're going to write it below the line. And I always do an arrow to take up that space in between my line of numbers and my baseline here. And then I bring down that 1. The number below the line, we multiply it by the number in the box. So negative 1 times 1 gives me negative 1. And then we're going to add down that column. Negative 1 minus 1 gives us negative 2. And we're going to repeat the process. So negative 2 is below the line now. Negative 2 times negative 1 gives me positive 2. We're going to add 2 plus 2 gives me 4. 4 is written below the line. 4 times negative 1 gives me negative 4. I'll write down negative 4 under the 5. And then I'll add down that column. 5 minus 4 is 1. Okay, so I've done a weird thing. Let's talk about what it means. So I like to mark it up so that I know what I have, so I can answer correctly. The 1, any number in this position where the 1 is on the bottom right is the remainder, and I always draw a box around it to mark it off as the remainder. And sometimes you'll have a remainder of 0, meaning it divided evenly, and sometimes you won't have a remainder of 0. Moving to the left is my constant term. So the 4 is my constant term in the quotient. It doesn't get an x, but I am going to mark it as positive 4 because we have a polynomial here. All right, moving to the left, I have minus 2. Minus 2 is the coefficient on x. X is one level up from the constant term. I got a constant, I got an x. I bet you can guess which one comes next. It's the x squared. So I'll move 1 over. I have a 1, and I'm going to write an x squared next to it. So underneath that line, I have 1x squared minus 2x plus 4, and then I have a box with the remainder. All right. So we're almost done. We just need to rewrite this in a way that makes sense as a quotient. So my answer would be x squared minus 2x plus 4 plus, like we did before, 1 over the number we're dividing by, x plus 1. So that would be my final answer to this division problem. And if you watched the previous video, you'll know that was the answer that we got on the previous problem as well. Okay? All right, so for this next one, this is another problem we did in the long division video, and now we'll do it with synthetic division. Remember, in long division, we had to add in terms for x squared and x since they don't appear in the numerator of our fraction. I probably should start by telling you the problem. It's x cubed minus 1 divided by x minus 1. And since we don't have an x squared and an x term, we'll have to place zeros for that in synthetic division as well. All right, so I'm going to start by writing out the coefficients of the number we're dividing. And so I will have 1 for x cubed, 0 for x squared, 0 for x, and minus 1 for that constant term. I'll skip some space, draw a horizontal line, and then up on the left, I'm going to box that off and figure out what I need to put in the box. So remember, just like before, we said what value of x would make that denominator 0? So x minus 1 equals 0. So x equal positive 1. 1 is the number that goes in the box. You might also hear this said as inside lies, which we talk about sometimes in college algebra, meaning we're going to take the opposite of this constant right here. Either way of approaching it works. All right, so remember the first thing we do is we bring down that first number, 1, and I'm going to write a 1 below the line. 1 in the box times 1 under the line gives me a positive 1, and I'll write that underneath the 0. 0 plus 1 is 1. I'll write the 1 underneath. All right, 1 in the box times the 1 underneath the line gives me a positive 1. I'll write that next to this underneath the second 0. 0 plus 1 is 1, so we get another 1 underneath that line. Finally, 1 times 1 gives me positive 1. I will write that underneath the negative 1. Adding down that column, negative 1 plus 1 is 0. All right, so notice on this one, I have a remainder of 0, which is pretty cool. That means it divides evenly. Then let's work backwards. The number closest to the remainder is 1. This is my constant term. I'm going to add a plus because it's not negative, so it has to be positive. And then I'll move to the left. I have another 1. That will be the coefficient on x. And I'm going to add a plus there as well. And then I'll move to the left again and add an x squared. So my answer would be 1x squared plus 1x plus 1. We would really write that as x squared plus x plus 1. We don't have a remainder, so I don't need to add a fraction on the end. All right, let's look at a couple more of these. I have two problems. The first one is 2x squared minus 3x plus 5 divided by x plus 2. I want to encourage you to pause the video and try this on your own, and then restart the video to check yourself. Okay, welcome back. So to divide this, we want to start by writing the coefficients of the numerator. So I'm going to write those across 2, -3, +5. I'll skip some space and draw a horizontal line. And then I'll put the little box up to the left. I'm dividing by x plus 2, so the number that goes in the box will be -2. Remember, it is the value of x that would make that denominator 0. All right, let's pull down the 2. So I'll rewrite the 2 below the horizontal line. Multiply it by what's in the box. -2 times 2 is -4. So the -4 gets written below the -3. Add down the column. -3 minus 4 is -7. I'll write -7 underneath that horizontal line. -7 times -2 gives me +14. I'll write +14 underneath the 5. And then 5 plus 14 gives me 19. All right, 19 is my remainder. I'm going to put that in a box. The number to the left of it, -7, is my constant. I'll leave that alone. And then the number to the left of that is the coefficient on x. So that will become 2x minus 7 plus, that remainder would be 19 over x plus 2. So my final answer would be 2x minus 7 plus 19 over x plus 2. All right, one more. 3x to the 4th minus 12x cubed minus x plus 2 divided by x minus 3. Again, pause the video, try it, and then come back. All right, let's write the coefficients of the number we are dividing. Notice I did something sneaky in here. I do not have an x squared term, so we're going to have to add a 0 for the coefficient on x squared. Very sneaky. Be watching for that. All right, so the coefficients would be 3, -12, 0, -1, +2. I'll write those across, skip some space, and then draw a horizontal line. In the box, I will have the number 3. Remember, that's the number that we would plug in for x to make the denominator 0. All right, the first 3 goes down below the horizontal line. 3 times 3 gives me +9. I'll write 9 below the -12 and then add down the column. -12 plus 9 is -3. So -3 gets written below the horizontal line. 3 times -3 is -9, so I'll write -9 under that 0. Add down the column. 0 minus 9 is -9, which gets written below the horizontal line. Then 3 times -9 is -27. I'll write the -27 below the -1. Add down the column to get -28. And then finally, we're in big numbers now. So 3 times -28, let's see, that would give me 84, -84. I'll write that below the 2. 2 minus 84 would be -82. All right, so kind of ugly numbers, but that's okay. We know what to do with them. So that -82 on the far right is my remainder. I'm going to put it in a box. The -28 next to it, that's my constant term. We don't want to change anything. The -9 next to it is the coefficient on x, so I'll put an x next to the 9. The -3 to the left is the coefficient on x squared, so I will put an x squared next to the 3. And then finally, that first 3 is the coefficient on x cubed. So I will write an x cubed next to the 3. For my final answer, I would write it 3x cubed minus 3x squared minus 9x minus 28 minus 82 over x plus. Oh, that wasn't a plus, it was a minus. X minus 3. Okay, in the cases where you can use synthetic division, it tends to be a little more straightforward and error-proof. Maybe not error-proof, but less likely to make errors than long division. So I'd encourage you to use it when you can.